on this one. All right, welcome back. We are COMP397 in the winter 2021 semester at Centennial, and it's week 4, part 2 of our broadcast. We just finished talking about assignment details, and now we're going to get into talking about, or actually doing the lesson for today. So today's lesson is all around cameras and what they are. So I have a bit of theory that I want to go through. So a camera component is just like any component in Unity. You have the transform, and then you have a lot of different properties that we have to go through. And I've detailed most of them here in the PowerPoint. And I've just used this as reference. By the way, like I mentioned last time, on the course shell, which is inside your course, I've also included additional information about, hey, what's a camera? And step by step on including a camera, those kind of things. A lot of the same information is here. I think there's some really good information that's been embedded. How to create a scene. You know, it talks about how to create a scene. Different kinds of, again, different kinds of terminologies, the properties of a camera. Things that we're going to be talking about today are things like the near plane and the far plane. And anything that's basically rendered, which means drawn, inside of between these two planes here, and they're invisible. You can't see these things, but we define them in the camera. Anything that's in here can be drawn, can be seen, is rendered, as I would say. If an object exists, but it's outside of the frustum, this is what this thing is called, the camera's frustum, then it is in the game world, but is not drawn. All right. So even if it's something that's renderable, a renderable item, but it's not in here, that means it's off screen. Okay. So that's why it's not being drawn. So that is a little bit of terminology there. We're going to go through it. And then there's a difference between this is a perspective view, perspective projection, and this would be your orthographic projection. And notice how the orthographic projection is the same size. So it creates a different effect than it would from your perspective projection. So please take a look at some of these notes that are here. I'm not going to go through all of them right now for you. These are for you to go through and look at, and so on. I also talk about characters, camera, and controls, some design that I talk about, as well as the nuts and bolts of mechanics. And this is very interesting. In the nuts and bolts of mechanics, I also talk about different kinds of platforms, moving platforms, opening, closing doors, pushable lock switches and levers, and so on. There's a lot of stuff in here that you can look at in terms of what I'm talking about. And I'm going to do more this week in terms of mini-map and so on. And that's what these lectures are for. I add more content for you guys as we go. So like, again, let's start off with something we were working on last week. So if we bring up Unity Hub, first thing to look at is what did we work on with last week, right? So last week we were working with COMP397. If I scroll down, this is a test that I did with another student. But if we go back, we can see that COMP397 lesson 3A is something that we did. We want to work off of lesson 3A and continue. So we can go to GitHub to download that lesson for ourselves. So let's go to github.com and /Centennial College, and you'll see that there is going to be a couple of links. One of them is lesson 3A, and then lesson 3 build. Lesson 3 build is kind of an excerpt from lesson 3A. I talked about that last week. Lesson 3 build is just the builds folder that's been included here so that I can build it, and I have a live view on online. So if I go to this little check mark, or if I go to this little environments area right here on the COMP397 winter 2021 week 3 build, I should be able to see the deployment, and you can see that this is what it would look like. This is the live build on the web, and it's right now it shows a little start button. We're going to improve that. And I've also got a little bit of what looks like a very, very fast motion, which we can improve today. I can somehow jump around and move around basically, but that's what this thing does from last week. And then we have a little pillar, and I went through the details of how to put that little pillar together for your little lab. And this is all on the web. Okay, there we go. So that is what this is, this week 3 build. But we're not going to start from there. Where we're going to start is from here, from lesson 3A. I'm going to download this lesson 3A. So I'm going to go there just to start off, and you can start with me. I'm going to download the code if you want to see the process again, or you can wait. If you want to wait till I put up the starter, that's totally up to you as well if you want to follow along that way. But notice that I'm going to have a lesson in a second. So let's go into my desktop. So I'll bring up my desktop view on File Explorer. Just a second. Just doing it off screen here, just to make it quicker. So here's our lessons from last week. We have a couple of examples I was working with students on. Lesson 3A is what we had. I could copy paste, but I'm actually going to download like you. And when you download, you're going to get this asset 3A. Remember that whenever you download anything that I've given you, you do not want to use WinRAR or the built-in extraction tool that's inside of Windows. You'd rather use 7-zip. So if I right click here, if you have 7-zip installed and you go to 7-zip and then you go to extract, that is the way that I prefer you to do it. You'll have less challenges and issues doing it this way. And then I can just rename this thing on the outer level to lesson 4A, which is where we're at today. So that is going to be the lesson that we're going to use, 4A. Let's add this now to Unity Hub. So again, going back to Unity Hub, I need to add it to the project so I can start it. So click Add, and then go to the project. So again, I'm going to go to Desktop. I'm going to find Centennial, COMP397, and swim to that particular lesson, 4A, that I just downloaded and renamed. And then click Select Folder. It's going to appear here in Unity Hub, okay? And when I click onto it, it's going to load our Unity project. Now, things to note, and people have had confusion about this, but things to note, when you first load the thing you download from the internet, from GitHub, what you're going to get is a scene that is empty. It doesn't mean that things didn't load properly for you. It means that you need to double click on the scene you want to start with. Because, and why is this happening? Because we've destroyed or gotten rid of the library folder that comes with your project. When your project is started, like what's happening right now, it's recreating the library folder that's inside of your project files. And when it does that, it kind of makes references to each of your assets and a bunch of other stuff. It really sometimes almost re-downloads some stuff and so on, things that it's needing in its project requirements and project files. Because there's a registry of all the files and dependencies that you've downloaded, and it has to work. So notice when I open it up, it's empty. And you're like, wait, I've gotten comments like this. Wait, Tom, I don't know why, but my thing is empty. Yes, it looks like it's empty. But notice that in my assets, I've got a bunch of stuff. You need to go to your scenes first when you first download this thing and double click on the scene you want to start with. For right now, I'm going to start with main, but start is my first scene. Let's start with main. So when I start with main, I'm back to this. This is where I have now, I'm going to start with this the entire time. And that's totally fine. Okay, so this is where we're going to start. All right, I'm going to save that scene. So File, Save Scene. Save Scene. And I'm also going to save project. And on top of that, what I want to do is immediately switch into the proper build setting. Right now, I'm sitting at PC, Mac, and Linux standalone build. That is not the platform that I want you to build for. I want you to build for Webgl. So let's click on Webgl, please, and then click Switch Platform. Now, again, this is only if you're following me. If you're going to wait, then I'll put this up on GitHub in a second, and you'll have all this stuff done. However, this you'll have to do anyway, because when I put it up on GitHub, this part won't change, because this setting, as well as looking at your scene, which scene you start with first and all that stuff, it has to be your library folder keeps track of all that stuff, and we don't push library folders up to GitHub, so therefore you have to do this again anyway. All right, but everything else, like your player settings and so on, they're the same. The only thing we want to change is from lesson 3A to lesson 4A, so it's named correctly. That's one thing we want to change. And then I want to save the scene, and I want to save my project. Okay, and once I've changed everything and done this, I can shut this down. And just like we've done in the past, I'm going to pull up GetCrackit, because I'm going to use GetCrackit as my little tool of choice this semester to make it easier for you guys. That's what it's for. And what I want to do, by the way, you can get rid of some of these tabs, like for some of these older tabs like 1D and 2A, because we're not going to talk about that again, or even 3 and the builds folder. I don't have to go and look at those anymore because, we're going to do it again anyway, right? So let's open up a new tab. Here's a new tab. And when I do that, it's asking me for, what do I want to do? Do I want to clone an existing repo? Do I want to start a new one? I want to start a local repo, but it's got to point to the right spot. So I'm going to go browse. I'm going to go to desktop. It's going to go to Centennial, and I'm going to go into COMP397, but no further. Please do not go into these actual folders. We're going to just go to the containing folder, COMP397, and then point to the folder we're going to do in GetCrackit. So click select. So this is the outer folder, and then the name of the inner folder is what we're going to put here, which has to match the name of the folder, which in this case is lesson 4A. So that's what we're going to put here, lesson 4A. And to notice, if you doubt it, if you click browse again, there's lesson 4A, but we got to put the whole name, not just this. So COMP397 W2021 lesson 4A. Let's do that. So again, it's COMP397 W2021 lesson 4A. That is the full name. People have done weird stuff where they don't put that in. I don't need a Git Ignore file because I already have it. I don't need a license file. I don't need a default branch. It's going to choose main for me. And then I'm going to click create repository. Excellent. This makes a repository locally, but it doesn't add any files. I want to click over here to say stage all changes. And then I stage all my file changes. And I need to make a small commit, which is the snapshot message. It takes a snapshot of your screenshot. And I'm going to name it. I'm going to say added project files. There we go. And then I'm going to commit changes to 74 files, and it applies that message to all the files that have changed. The files that have changed because I've downloaded everything, and I created a whole new repository. Okay. So that is what this is. And then what I want to do is go push. But when I push, it says, hey, you don't have a remote. There's no connection. Do you want to make one? Yes, I do. And then if you've given GetCrackit permission, it's going to allow you to pull down your account, which is mine, in this case, Centennial College. Yours will be your account name. And then I have my new repository, COMP397 W2021 lesson 4A. And then I'm going to click create remote and push local references. And if I did everything correctly, and if I didn't mess up, it's going to do its little dance. And on the bottom left corner here, you're going to see this little bluish message. There it is. Come up that says, hey, it's good. You're good. Let's take a look at that repo. It's going to bring up the repo, but there's one more problem. Our README file, it says lesson 3A. Let's change it online to show you how that's done. I'm going to go up here, and I can rename this to 4A. There's 4A. Save it by committing my changes. But now what's happened is we're ahead online on GitHub is ahead of your local branch. And if I go here, you can't tell, but if I go to where it says pull, and if I go to fetch all, then you're going to see that there is a difference. I'm out of sync between the main branch online and my local branch. And the way to do this is, of course, to fully pull from my origin remote, which is going to download and install my readme.md file. This is it, and it shows you the changes that have been made. Red means subtractions, green means additions, and you can see that I've modified my lesson 3A to say lesson 4A. That's what's happened. Yay. Really exciting stuff. All right, so now that I've done this, yes, everything's nice, I'm going to give you this lesson 4A as a starter. This is the starter code. So I'm going to copy this and go into, eCentennial, up on our course shell and under content. And there's an area that's in week 4 called GitHub repos, where I'm going to put a new link. This is where you start for your lab for your next lab 4. Yes, I think it's lab 4 we're doing today, or is it lab 3? I can't remember. And let's put the proper title where it's supposed to go here. And this is week 4's GitHub repo. Okay, and that is the link for you guys, just in case you have a problem. You can always start from there, and then you can go through some of that process with me, not the whole thing. Or if you're watching another day, then you just start from here. Okay. Now this starter is going to be complete by the time you see it. So this here is, if you downloaded this, you'd have everything, right? So I'm not looking for you to download my code, and I've seen some of that too. You download my code, and then all of a sudden, now you do everything that I do. Well, that's not the exercise. The exercise is, this is code for you to compare my code to your code. All right, it's not for you to submit my stuff back to me. Okay, if you submitted my stuff back to me and it's purely me, like everything is me exactly, and there's zero changes, you're not going to get a mark for your lab, guys. All right, your lab has to be your work, your stuff. You have to swim through it and do everything yourself to make sure that it works. Okay, so this is just, if you want to start right now, if you're with me at this point right now and you're live with me, this is where you start. If you're another day, then you wouldn't start from here. You're going to make your own and compare yours with mine. Okay, that's what it is. Compare yours with mine just to make sure that you can do what I can do. It's not, the exercise isn't just like hand it back to me. Okay, what's that going to do? Nothing. All right, so that is, let's go back. So I'm going to go back to Unity now. So here's my Unity hub. And I'm going to launch lesson 4A. And now I should be back in business. However, one thing we covered last week, which I'll cover again this week, is I want to build for Webgl. So the way to build for Webgl at this point, we need another repository. People misunderstood when I did this, but I'll do it again, is I went to player settings. And under player settings, I changed my resolution of presentation to whatever resolution I want. Right now, by default, it's 960 by 600. I'm going to change it to 1024 by 768. And what this is going to do is that's the size and resolution of your web page by default. So again, you don't have to change this. You can make it 800 by 600 if you want, or 640 by 480. But the smaller you make it, the worse it's going to look when it's maximized. Okay, so then this is this. And one other setting you have to change right now is, and this is talked about, is make sure you change the compression format if it's not already changed to disabled, because you don't want compression to be disabled. It seems to cause an error for a lot of us when we put things up. So make sure this is set to disabled compression format under publishing settings. Otherwise, everything remains the same. Save. And then I can click build and run. Let's do that together. Build and run. You want to select a new build folder outside of your assets folder. So let's go new folder. We'll call this thing builds. Okay, there's builds. And inside the builds folder, I'm double clicking in the builds folder. And this is where my build for Webgl is going to be created. So what happens is after I click select folder, Unity is going to translate my code and my scenes into a Webgl, so JavaScript and WebAssembly compatible folder that it's going to create that I can put up on GitHub pages. And again, let's click select folder. It's going to start the build process. When it does, you might hear me cutting in and out because I'm actually translating and building everything. So if I seem to cut it in and out now that I'm talking, it's because my computer's working very hard to compress and translate my textures and my code and everything else into something that's compatible with the web. This can take upwards between 1 and 2 minutes for the first build. And then each incremental build should, and I'm going to put emphasis on, should be faster. So please make sure you test this, because something that works in the Unity editor does not necessarily mean it'll work in your Webgl build. Doesn't necessarily mean that at all, right? Need to check both. And when we get into the second half of semester, you'll be using a whole other simulator to test that your Android game is working as it should in the simulator as opposed to just in your editor. Okay, so please make sure this is the process we work through, and I'm showing you this so you've seen a build before. One thing you can do is if you do build it, if you want to make your game in the future that it runs, you want to give it to somebody, you can always build it for PC, Mac, and Linux standalone, and then you get an executable on a PC or something that you can run on a Mac by running an execute command. But for us, it'll automatically run in a web page. So if you build it from Webgl, you have to give them the web link that we're going to generate right now. And that is what's going to be required. We're going to be practicing this every single week until week 7. So that way you guys can get this done, because it's a requirement of assignment 1, part 3. It's not a requirement of assignment 1, part 2. I'm not asking for it for this part that's due Sunday. I'm asking about it for the part that's due on the 28th of February. So that's assignment 1, part 3. And that's why I'm telling you now. So you've seen it a bunch of times because it can be quite complicated and it can take long, as you can see. All right, so I don't want you guys to be confused or worried about it. It's just part of the process. All right, so that's going to be finished in another minute. If you're watching the video, please fast forward while this is happening. You don't have to watch paint peel, which is like this loading. For example, you can see it takes quite a bit of time for this to go on, even with a pretty good system like mine. Okay. So if yours is a little older, or if you don't have good hardware or whatever, this could take a long time for it to happen. Okay, there we go. So what you get at the end is a little start scene, and when you press play, you get this insanity, which we're going to fix this week. All right, so that's pretty cool. We've got the files. Now let's close this off, right? And what it does locally, right? Locally, if in my COMP397 folder, let's go in there and take a look. You can see that inside of lesson 4A, it creates a builds folder. But our Git Ignore file, if I open up the Git Ignore file, let's say in an editor, like, I don't know, Notepad, you can see that it ignores, the Git Ignore file, this thing right here, ignores anything that's listed inside of it. So example, it ignores anything in the build or builds folder, whether it's named build with a capital B, lowercase b, or whatever. It'll ignore this folder, which means anything that's inside of it will not go up on GitHub. So if we look inside of it, that's what you need to go up on GitHub, your index.html. So I need to make a separate repository just for this. Okay, that's one option. Or you can just copy this whole folder, if it doesn't work for you, on another folder somewhere, and then go from there. But you need to build from here, from this folder here, and make a new repository in order for you to make this. If you're working with itch.io, by the way, itch.io is a place where a lot of games are shared, and you can do the same thing. You can create an account, register yourself on itch.io, and you can see there are a lot of indie games and examples up here where you can share your stuff online. That is another option. We're not going to do it this way. We're going to make it so it's working on GitHub pages, but itch.io is another viable platform, not a problem. All right, but let's go back to GitHub pages now. So I want to make a new repository, and I'm going to do it with GetCrackit. We did this last week, so I'll do it one more time. So I have my repository for my project. This is the project repository. Now I need one for the build. So I'm going to click plus. This is inside GetCrackit, and I'm going to go to start a local repository again. This time, though, instead of looking out here in COMP397 land, way out here, I'm going to go inside the lesson 4A folder, right, and select that. So it's going to be inside lesson 4A. I'm going to select that folder. And then I want to mention up here, it's the builds folder that I'm looking at. Okay, so this is the complete full path right here that you're going to see, the builds folder. I'm going to click create repository. I'm not going to add a Git Ignore file or anything like that. I want nothing to be ignored now. Click create repository. This is going to make a brand new repository in the builds folder. I need to add it as an initial commit. So I'm staging all my files like normal, second repository. And down in here, I'm going to say added all project files, which is what we just did. Commit changes. Now I'm going to push it as normal up on GitHub. And I want a new remote, but it's not going to be called builds. It needs to be called something that's reasonable, like COMP397 in the winter 2021 semester, and it's lesson 4 build. That is the build folder for lesson 4. It's separate than the regular project files. And then once I have that, if everything goes well, I should be able to create this folder. And if it says no, as an example, let's say, for example, lesson 4 build, for whatever reason, doesn't allow me to. Why would it not allow me to add it in? Right? Well, there's only one reason, really. It's if somehow I haven't selected my my place, my account name, or if somehow the build name is the exact same as something that already exists. So I didn't select my account name. That's why it didn't work. And if I click create remote and push local references, I should now not have any issues. Sometimes, though, you get an issue that says GitHub repo already exists. And then this way, you just have to pull it out into another folder. For us, it didn't happen. I still got this nice folder, which is view on github.com. And if I look up there, you can see certainly that this is what it is. Let's rename the README file, just so that we know what it is. I didn't do this last time, but I'll do it now. And inside my README folder, I'll say, again, it's COMP397 in the winter 2021 semester, and it's lesson 4 build, not builds, but build, right? And if I put a hashtag in front of it and a space, this makes it into a H1 tag equivalent for an MD file. Anything that's .md is a markdown file, and this hashtag, it just means H1. All right, cool. So now I'm going to say, I can put some comments like demo or folder to host the lesson for build for Webgl. Okay, that's what it is. And down in the bottom where it says commit changes, I can click commit changes. That means that up online, I'm one commit ahead from what I am locally. I'm going to go back into GetCrackit and I'm going to pull. And now I'm in sync again. Okay, cool. Excellent. So now that I've done this, I have my lesson 4A and my builds folder. I need to have both of those to continue today and for the rest of the semester. So when I have both of those two things, by the way, the builds folder, well, the rest of the first half of the semester, the builds folder will be a little bit different for the second half in that you're going to build it to an Android device or a simulator, which we'll talk about. But anyways, I digress. Let's go back to these two folders here, right? So I've got my regular folder and my builds folder. Let's put this up on GitHub so you can check it. So I'm going to copy this. This is the builds folder. And I'm going to go to our up online, so GitHub repos. You'll have the build folder now. Let's do that now. So I'll say create a link. And we'll call this, so this is something you can compare to. This will be, so week 4 build folder. This is not the live site. This is just the build folder. Think about this as your main folder for your web page, okay? But this is not the web page. This is just the folder for the web page. That's what this is. That's why I call it build folder. Now there's a separate thing for the live site, because when I go up online, I need to deploy this page. And the way to deploy this page is you need to go inside the build folder in settings, and you're going to go scroll down all the way to where it says GitHub pages and select the main branch and click save. I've shown you this last week. Now, because it's a WebGL build, my friends, it doesn't happen automatically. If it was just a simple web page, I can snap my fingers and it'd be ready. It's probably not going to be ready right now. And the reason for it is because it takes time to propagate across the internet and to build the WebGL files. You see how long it took on Unity. It's going to take some time. Give it a few minutes. And if you do, if you go back down here, you'll see that it'll provide you with the link that when it's ready, if you click on this link, it will come up and you'll be able to play live on Unity, right? Live on the web. Let me give you the link here so you can test it with me if you're in my here with me. As an example, here's the link. And if you're someone who's live on the internet, on YouTube, I'm going to post that link there as well. So you can always go back to that link and check it out if you're watching live on YouTube at this point. And there are a couple people that are watching live on YouTube. You can check it out and you can see that that link works anywhere in the world. That is what I want you guys to do by the end. Okay, so I'm not taking this down. Hopefully not anytime soon, and you'll be able to test this out. This is what I want for you now. You don't see nothing that's exciting at this point. You just see a little ugly start button, but that's okay because this is what we're going to improve on over the course of several weeks. Let's click start, and you can see now it's crazy fast because of it's in a build mode. Let's escape from that. We can also make it full screen. If I move down to here, I can make it full screen. And you can see again, it's like lightning fast because I need to make some adjustments to the build, right? And that's how it works. But you can see it works nicely in WebGL. It's totally up and you can try it now yourself. Okay, so that is what this is. Okay, so that link, if I go back to the builds folder, not this lesson 4A, but the lesson 4A builds folder, if I go back to build, right, this build folder has this little check mark. This check mark is a good indicator that things are okay. And also, this is also a good indicator that things are okay because it says environments, GitHub pages. Sometimes there's a problem. When you built it, it compiled, but it doesn't work. And the way you know it is, if it doesn't work for you locally, it won't work for you remotely. Okay, even though there's a page like this. So again, if I click this, it's going to give me a deployment. Here it is. I'm going to copy this deployment. Okay, and I want you to see the difference between the link here and the link that I gave you earlier. So if I go back to here in GitHub repos and I go new link, right? There's a different link. They're all different links. One of them is the project repository. That's the first one. This is your live. So this is week 4 live site. That's what this is. Okay, it's an actual web link to play the game live. That's what it is. Okay, they're all different. This one is your repository for your project. This one is your repository for your build folder. And this one is the result, the deployment of this folder. This deploys live with a different link than this one. Okay, there's 3 links. When you hand stuff in to me, I only need this one and this one. I don't need the build folder. This is like a middle step for you to make sure that this works. However, you need to maintain this. Please don't delete this one, because otherwise this will never work. Because this one is built off of this. Poof. Okay, so that is how to build for GitHub pages yet again. And I wanted to show you that because people had issues. They complained they didn't understand what I did and so on. And so I wanted to go through that one more time with you. Back to Unity. So I'm here. I've made my build. We can make an incremental build, no problem now, from here. Now I wanted to talk about cameras. And right now, if you notice, if you remember, I have this main camera. And the main camera, if you look at the, we have a little widget or a object here that you can see. It's a gizmo is what Unity calls it, that appears inside of the 3D scene. It gives you an understanding of where the physical position of the camera is in the scene. One thing to note about cameras, it's just like a regular game object. It has a position, rotation, and scale, right? And it also has a camera component. There's the camera component, and it has a bunch of different things here, right? All right, so sorry, Do Yoon says he found a bug in the game. Tile 2 prefab does not have a ground tag and a layer assigned, so the player cannot jump on tile 2. Let's try that. Let's fix that problem. So thank you for that. So if I go to models and if I go to tile 2, right, and I go to model there, I need to do 2 things on tile 2. Tile 2 is also prefabs under the resources folder. Resources prefabs tile 2, like you said, should be on the ground layer. The ground layer, you can change that here so that it's on the same layer as everything else, right? So that is important. Okay, and then we can save it. Now you'll be able to jump on anywhere on tile 2. One thing to note also, one more fix that I wanted to make before we move on, and I'll build it one more time, is inside of the materials. The materials, I created something called Stone Wall last week, and notice that I had it as standard specular setup. Guys, let's move this from standard specular setup to Autodesk Interactive. If you move to Autodesk Interactive, it actually allows you to use a normal map that's proper, an albedo, roughness, ambient occlusion, and a height map, right? And it does make a lot of difference when you put it this way. So please, again, we're changing the material for Stone Wall to Autodesk Interactive. I've also included inside here 2 textures, the Stonewall D and Stonewall N, but you can download the other textures, which I'm going to put up on, I think I put them up last week. If you go up on eCentennial, and if I go to content, and if I go down to week 3 under the areas here, you can see that I've also included additional textures up on eCentennial for the height map, the roughness, and the ambient occlusion. Let's use all of these today to fix that up. So again, going back to my my structure, if I missed something from last week, which I did, I have Stone Wall, and I have this one and a bunch of them, right? Let's put the other ones in place too. So I want to include my ambient occlusion, my height map, and my roughness. I'm just going to drag and drop those from off screen, just inside of the textures folder. You can download these from eCentennial and you'll have them. We just need to rename them. So this one is an ambient occlusion map. So you can see that it just highlights the darker areas. So we'll just rename this. So it should be named Stone Wall AO for ambient occlusion. Let's also rename this one from Stone Wall H for height map. And this one will be Stone Wall, not a lot of information on this one, but on Stone Wall underscore R for roughness. Now you can see that it's not a great deal of information for roughness, and that's why the roughness values aren't so great. It's not that rough. Other materials that you might create might have a higher roughness value. You actually see it here. Okay. So now that I have different textures, let's modify that material, and you can go back to that material, which is Stone Wall. By the way, you can even rename it, and it'll rename everything that has a part of it. It'll do a refactoring. So don't worry if you name it here, you don't have to worry about it like breaking anything. Notice it didn't break anything out here. But now I can drag and drop from my textures folder into my materials folder in the right spaces. For example, inside the occlusion space list, drag and drop the ambient occlusion. It has a space for that now. Inside of the roughness map list, drag and drop the roughness map. There, it does that too. You can see that there's a new preview here of what it's going to look like. And the one that makes a huge difference that you'll notice is the height map. If I drag and drop the height map inside of where it says height map, then you'll see that it looks a lot different. And if I look now at the wall, here's the wall. This is the final effect. And it looks a little better than before. My normal map, by the way, it looks like it's 0.25. Let's drag that a little bit higher, and let's see what the effect is of this. This is just a review from last week. If I drag it to the right, you can see that it gets darker, and it looks like there's more detail as I move towards, let's say, something like 0.5 or 0.6. Let's put it at 0.5 this time around. And then in my height map, this is where it becomes really dramatic. If I move my height map beyond what it is, it'll look like the actual tiles are changing. While I'm doing that, please balance them so that it looks realistic, and you're going to see a better effect than you would if you didn't have a height map at all. So it looks like it's got geometry when actually it's right flat. Where you're going to notice the most is if I actually had geometry, I can actually notice how it actually changes what the texture looks like to make it feel like there's geometry there where there is. So you have to kind of adjust it by eye to see where it makes the most sense. I think that looks around right. So about 0.677 is what I have my value at. Occlusion, there's not much occlusion here, so it's not going to really work great. If there was a different occlusion map and a roughness map, then you'd see more details here, more shadowing inside the bricks and so on. All right, so that is finishing off our material. All right, so you can see that looks a lot better than it was before. One thing to notice is even if I put the material on the other parts, because this hasn't really been UV mapped in Blender in any way, then you have all this really weird situation happening. We're going to leave it like this for now because it's not that important to me. And chances are the lesson that we talked about last week, you're going to be using your own assets that you downloaded from the asset store or from someplace else. Let's save this thing. But we've made some changes to the material, and that's good. All right, so back to the PowerPoint for one sec. So I wanted to talk about where we are. So we talked about that cameras are just another game object. The cameras have an additional script, custom script that's been written for cameras that's built into Unity. One of them, and there's a lot of new properties that they open up for us. But let's talk about a couple things. Clear flags, it really determines which parts of the screen will be cleared. And this is really handy when I have multiple cameras. So we're going to talk about that. Right now, by default, if I go back, you can see that under my player, the only camera that I have is inside of my player character. Here, this one. And this player camera this is a preview of what the camera will look like. You can also look at the game to see what the camera is seeing, okay? By default, this is what the player will see starting off, okay? But notice clear flag says skybox, because by default, I want to see my procedural skybox that comes with Unity, all right? There's other options. And what we're going to do later on is we're going to use something called solid color when we make our little mini map on the top right corner of the screen, okay? Also notice on main camera, we have some additional values here. Background, which is default background color. Calling mask. Calling mask means that what layers does the camera see? Right now, the camera sees all layers, including the ground layer, water layers, if we had some, and a bunch of other things, even UI layers. The camera sees them all. So that way, by default, the camera sees everything that you put in the scene. But you can adjust this so that there's certain things it doesn't see. For example, let's suppose I don't want to see the ground layer. If I check this off, suddenly the camera's view doesn't see anything. Like, it looks like we're floating. It exists, we just can't see it. So that's what this does. Culling mask allows us to hide things from the camera or show things in the camera that exist or do not exist in the scene. All right, so that's number one. The next part is projection. Right now, by default, we are using something called a perspective projection. And going back to Blender, just as an example, I don't need you to do this, just so that I can show you the example. Blender has a camera. Here's the camera. And right now in our viewport, we can see that our object is in perspective mode. If I switch to orthographic mode by hitting the numpad 5, it looks weird. It looks different, right? So what's happened is I'm not using the frustum, the near plane and the far plane. They're the same size in this case, as opposed to the near plane being smaller and the far plane being larger, to give us that sense of objects that are farther away appear smaller and objects that are closer up appear bigger. That's perspective. This isn't that. This is orthographic. Orthographic projection, everything is the same size. So this is what we use for 2D gaming a lot of times, or to create an isometric kind of look and feel as well. So this is orthographic projection. If I move my object in Blender in orthographic projection, you can see that no matter where I move my square or my cube, it appears to be the same size. But if I switch projections, now if I move my cube along the same axis, notice it appears farther away because I'm in perspective mode. Perspective mode, objects that are farther away appear smaller. If I move back to orthographic mode by a click, you can see now that, well, if I could see it, it's the exact same size as something that would be closer up. For example, something that's over here, same size. Whereas, switching back, it's farther away. Why? Because I'm in a different perspective projection is what it's called. Back to Unity. So this is just to show you what it looks like. If I go back to Unity, we're in, by default, perspective projection. You can see that that is how the camera views the world, in perspective projection. However, I can switch this projection. If I wanted to make an orthographic camera for some reason, I can switch it to orthographic, and then it sees things differently. You can see that it sees everything flat. Of course, that doesn't work for us in a 3D world. Let's switch back to perspective. As you can see, now we're back to the regular 3D way of looking at things. All right, so let's go back. So difference between, perspective and orthographic. This looks a lot different than this. And that's what I showed you here in the on the PowerPoint. By the way, this is all from Unity's. I've just taken excerpts out of Unity's manual to share with you so you can pinpoint those areas that you need. Instead of me going online and showing you there, it's just preserved here for you guys to look at, so you don't have to search around. So that's what orthographic is. It allows things that are the objects, like it says, to render uniformly, as opposed to things that are farther away to render small and things that are closer up to render big. Other properties that we can see are, if I go back to Unity, you can see that there's many other properties here. FOV Axis. This is field of view axis, which is vertical. There's also horizontal. It just changes the field of view, how you can switch the field of view up. We can also make this a physical camera, which will look a lot different than if we made it almost like you're holding a camera in your hand, as an example, or it's an actual camera with many more details. For example, focal length, and just like as if you had a real camera in real life. If you're going to create a movie-like effect, or if you wanted to run with the camera and have shake happen and everything else, make it more realistic, you would turn this on, but there's a lot more details, and to make it look realistic, I mean, it would really monkey with our character if we did this, right? Like the look and feel of the camera, it looks a lot different when we're looking at it as a realistic kind of camera. The field of view is changed, focal length is a lot different, and our shadows look a lot different, and the way we look at things, like we're holding a realistic camera, and that's not what we want in a first-person perspective view. So let's go back and click this off. Again, you can see that that changes a lot of stuff. The near plane and the far plane is just like we said. This is in unity units, so meters, if you will. So the near plane, so the closeness to the character's eyes, is 0.3 away from the camera. That means 30 centimeters away from the camera is where we start rendering things. We start drawing things. And 1,000 meters away is how far the character can see. Wow, that is like really far. And sometimes what we do for performance reasons, especially on mobile, is we chop that number down to like 100. Look, if I chop this down to 100, it wouldn't do anything in my preview. It's the same. We don't have a very large scene, right? But if I chopped it down to 10, well, then we're going to see that we don't see a lot of stuff. There's almost like a fog of war, right? Like we don't see very far away at all. So if I was to run the game with only 10 meters, wow, like we only see like, very close up. You can see as I move, then the objects start to appear. They start to render, but only 10 meters away max. And it gives us a really weird look. It can make you a little sick if you're looking at it because you're like, whoa, how's that coming into play? I don't recommend this. I recommend at least 100, right, as an example, if not 1,000. It's okay to put it 100 for us. 100 meters is like pretty far away, okay? And then you can add other things like fog effect and so on. Let's put it back to 1,000. As you can see, there's no difference because we don't have 1,000 meters of information that's in here. But if we did, then it would render way up into 1,000 meters, or 10 times farther than this. The longer this the far plane is, the more it renders, the lower your performance. Okay, because it has to draw everything in the scene that it can see, that your camera can see, even if it's very far away. Okay. So that is the near plane and the far plane. Viewpoint rect, what this is where the camera, I'm just looking at the game scene now, where the camera appears. It is in normalized coordinates. Normalized coordinates. This tells you how much of the viewport each of the cameras take up. For now, it's taking 100% of the viewport width, this whole width, and 100% of the viewport height, this whole height. It's 1 because it goes from 0 to 1, where 1 is 100% and 0 is 0%. If I put 0.5 for width, we get a split screen because I can only see half of the viewport. All right, the other half, there's no camera on that side. So if I was to run the game now, you're going to see a black area, right, all the time. Like there's one part of the screen I don't see. It's a split screen, up and down. Okay, that's what that does. Okay, and you're going to say, why do I want that? Well, what if I have two cameras, one for one player and one for another player? You can do that kind of stuff. You can split screen, right? So width 0.5 tells me it goes from the left because my camera renders. We're going to see where my camera renders in a second, but it renders half the width. What if I said half the height as well? Half the height, you can see that the default, the 0 point where my camera starts to draw is bottom left corner. So this is the bottom left corner of the screen, and it's half the width and half the height. If I wanted to make the camera draw up here, then I would move the X coordinate, half the width and half the height. So I could say something like 0.5 and then 0.5. And you can see that the camera, I can have 4 cameras or 8 cameras or however many cameras I want. But now this camera is only rendering in the top portion of my viewport. Nothing is rendering here. It's black because I don't have any other cameras. If I want this to go back to normal again, then I make the width 1 and I can make the height 1. But I can also have to start off with these as zeros. And then I'm back to normal again. If I want to make a horizontal split, then, so for people who are online, I want to make a horizontal split like in Minecraft or something, or in other games where I have a player on the top and a player on the bottom. How do I do that if I want to make couch co-op using these normalized coordinates? Can anyone help me out? So I want to make a split screen where I have a player on the top and a player on the bottom. So, okay, there we go. So Vanko says height is 0.5. Let's try that. There we go. And now we have the player on the bottom. If I want this one to be on the top, I would just change the Y coordinate so that I can make it appear on the top, right? So that is where it appears. I can make a top player and a bottom player, if that makes more sense to you from a split screen perspective. Okay, now you know how to do split screen. It's not that difficult. In fact, it's super easy to do split screen. You just have to have more than one camera in the screen, in the scene at the same time, right? And they can be controlled by different players, right? All right, so that is this part, viewport rect, which we don't touch very often unless you have multiple cameras in the scene that are rendering at the same time, okay? Depth. Depth is layering. So sometimes if I have more than one camera, I want to give cameras the ability to layer on top of each other. I can see multiple things being rendered one after the other, and that is depth. Rendering path, I can choose some advanced settings, HDR, MSAA, those are also part of graphic settings. Allow dynamic resolution, I wouldn't choose these right now, they're just advanced settings, leave them alone. Audio listener, your audio listener, there can only be one in the scene, and the audio listener is how you hear sounds. The closer to the audio listener you are for sounds that are being made, then the louder the sound is. If the audio listener is not on the camera and it's somewhere else, then you'll hear a sound that's louder as you get closer to it. As an example, to the audio listener, whatever that thing is. But it doesn't make sense. Normally, the audio listener and the camera are in the same spot, okay? Like the person's eyes and the person's ears. They're in the same area, right? They're not separated typically. But if sometimes they are, then you can separate this audio listener component into somewhere else. But you can only have one. Then I have my own custom script, which I put in last time, which controls my camera. Notice my mouse sensitivity is 1000, which is what's causing my issue to happen and when I'm building for Webgl. And the reason why this is happening is, if I look at my camera controller, if I double click on this thing, it's going to bring up Visual Studio, and we are going to get to this place where I am going to launch Visual Studio, and I'm going to have my code here. Notice what I did for doing this. I had a mouse sensitivity, and I had in my update function, I multiply by time.delta time. Time.delta time, what it does is it's the difference between ticks on the clock. So in other words, like when I have my initial time for every, it kind of counts between each frame. Remember, each frame is, in this case, by default, it's 60 frames per second, which means every 16 milliseconds approximately, depending on your hardware. So the average delta time is going to be something like 0.016. If I take 0.016 and multiply it by mouse sensitivity, which is 1000, you're going to get something that is much smaller than, 1000, right? But we can do better than this. We can make it so that instead of its time.delta time, we can give it a sensitivity value, and it has nothing to do with time.delta time. Now, be careful. When we do this, then it'll be machine dependent. Time.delta time will smooth out the mouse motion and make it so that it is consistent. Example, if I take away time.delta time, right, completely from my mouse motion, again, I'm looking inside the camera controller script to do this, right? And if I save this, and let's change my mouse sensitivity down a lot lower. So instead of it being 1000, let's make it so that it is 5. All right, so now I've taken away time.delta time, so that is valid. So I'm moving from a mouse sensitivity of 1000 to 5. All right, there we go. And let's save. If I run this now, and let's see what craziness happens, right? Does it make sense? Yeah, look at that. It still works. But it depends on your machine now, as opposed to it's not as machine independent this way. Okay. Now, if you like this, this is okay, and you can adjust your mouse sensitivity, right? If you like a lot more than this. Okay, but you can see that again. You may want to change this to be a little bit less sensitive. Even 5 might be too much for you. Okay, this is my screen. You can see that it's pretty good here. How does this look when I'm running it on Webgl? Let's build locally. So again, I'm going to stop this and go File, Save Project, and then File, Build and Run. Okay, this is not going to build for the web. It's going to build locally to me, locally, right? And this is going to also change your builds folder. It's going to change your builds folder. So if I wanted, the next step is for me to push my builds folder to the web. I'm not going to do that yet. I'm going to test it locally first, make sure that it's working okay, and when I'm ready, when I'm satisfied, instead of me going through this build process 10 times, I'm going to check it locally and then push it, because pushing it takes a lot longer and it takes longer to propagate than trying to make things work locally. Why it takes a long time now and it's redoing everything is because I've made a lot of changes. Franz says, do you recommend with or without delta time? I think for now, for our mouse, we're going to remove it because we have such a difference in WebGL, right? As an example, where we made our custom mouse controller, and I'm going to remove it, and I'm going to show you what it looks like. What's the difference between what we see on WebGL and what we see on, inside of our editor. Our editor is actually going to run faster, and it should be relatively the same speed for you, for your system, in WebGL. Relatively the same speed. Why? Because you're testing it with your system. Now, if you tested it and I built it, it might work really fast. And this is where we have to make some adjustments to our script later on. Right now, it's just a basic script to make you go. You can also download your own character controllers from the Unity Asset Store. I'm totally fine with that. Where there's more advanced functionality with some advanced character controllers you can download as opposed to the little script we made here in our code. Okay? You don't have to use my character controller, is what I'm saying, if it makes sense for your game. So let's wait for this to be finished building, and then we'll go to the next step. But I'm showing you all the details. I'm showing you again, we're just doing a bit of a review from last day and also talking about cameras so that you know what it all means. Let's see what my camera looks like now when I'm live. So now I'm live. Okay, that's not terrible. It's not like as crazy as the other one. Still pretty fast, but then we saw that it was pretty fast even for me. Let's make it maximized. Let's maximize our camera, see what it looks like. And you know what? It's not bad. It's pretty good in terms of things. That looks pretty close up because of our field of view. And there's a bit of a bump. See that little bump there? That's because of the way we're bumping against the ground and we're kind of colliding with the ground at the same time. Okay, that's why it looks so janky and weird. Okay. Let's escape out of there and talk about our local build, why it looks so big and what's happened to our camera. Because remember, our camera, we went into it and we changed it from perspective to orthographic and a bunch of other stuff. So here I am in perspective view, and my field of view has been messed about. My field of view has changed to like 26. This should be something like at least 60, something like that, if not bigger. So if I change my field of view, that might look a little bit more natural to you. Some people like to have a really big field of view when they're playing a game like Apex Legends. And a lot of times the field of view can be something like 90, which is makes the game play. If I just play it locally, it plays a lot differently. So you can see that the field of view of 90 makes it look like you're looking through a fisheye lens. That's what it's looking like. Okay, that's what a field of view of 90 does. But if I change that, let's go back to a field of view of about 60. And if I play the game locally, not building it, but play the game locally, this is a good way of checking it. Now this looks a little bit more natural again for us. It's not as bad as a field of view of 90. All right, there we go. Okay, so that looks pretty good. And that is what we want to build with, a field of view of 60, approximately. Some people like it 50, some people like it bigger, but you have to adjust yours for your game. Okay, so that is field of view. And then we have other things. We have a depth, like we said, and a target texture. And this is how we're going to do our mini map. Let's get back to this. So we've talked about a lot of little concepts here for our camera. We've talked about the idea of a near plane and a far plane. And this is the near clip plane. And this is inside of clip space. Inside of clip space is between the near plane and the far plane. We're just talking about terminology, guys. 3D graphics. And the clip space is between the near plane and the far plane in orthographic mode. Notice that in orthographic mode, everything looks the same size, no matter how far away it is. And notice the green ball is outside of the frustum, of the camera, right? It's outside of the frustum, which means outside of this viewable area. Even though it's in the game, we can't see it. It's in the game world, but it's not viewable. It's in the game world, but it's not viewable. The difference is this is the exact same area. The objects are not really differently sized, but inside of perspective view, the red ball seems farther away from the camera's eyes than the yellow ball. But here in orthographic view, both balls appear to be the same size because we're looking at it, the near plane and the far plane are the same size. It's not going to be skewed anyway. We're skewing the perspective, right? We're skewing the view, if you will. Anything that's inside of this really weird shape. It's not quite a cube, right? Here it's more of a cube or a rectangular prism, where here it's a rectangular prism that has a skew with a smaller area here and the larger plane over here. So this is the difference. Okay, so that's what we talked about that just now. As well, right, we also can talk about the viewport rect, which is what I talked about as well, where sometimes you have a split screen happening. We talked about that. That's here inside of your details. Also, notice that the rendering path, and there's options for the rendering path. I told you not to touch this because you can use player settings or graphic settings, vertex lit, which means everything is just regularly lit by the camera. There's no lighting. Forward rendering, which we talked about before as a default rendering mode, and deferred rendering or deferred lighting, which means that objects are drawn off screen and then rendered onto a full screen quad. All right, so those are different methodologies. If you have multiple lights in a scene, like many lights, you want to use deferred rendering because you want to render or draw things off screen and then compose everything and put them back on the screen. But there's an overhead cost to that, and it doesn't do transparency well. Whereas if I use forward rendering, I can have up to, let's say, 4 or 5 lights, depending on your video card, at the same time, very comfortably. However, transparency is done very well, and it is a little bit less overhead. If I had many lights in forward rendering, it would perform badly because each light would try to change the color of every pixel on the screen simultaneously, which causes a lot of computational overhead. Okay, so that is how the rendering path works. Target texture is what we're going to do. We're going to take a short break, and when we come back, we're going to design a mini map. We're going to talk about our mini map. That's the first little thing we're going to do for our lab. And what we're going to do is we're going to create a little target texture, a little area on the top right corner of the screen that's going to show a little mini map. And I've talked about what a mini map looks like way at the bottom of my PowerPoint. It kind of looks like this. You have a little bit of a top-down view, let's say, of your game, right? And there's almost like a second camera, right, that looks down on the game instead of from your character's eyes or from a third-person perspective. You don't look at it that way. You're looking at it from a different perspective altogether. There's an extra camera here that we're doing. We're going to talk about this after the break. Speaking of break, we're sitting at 4:52. I've been going for about an hour and 20 minutes or so. Let's take 10 minutes, and when I come back, we're going to work on our mini map. Okay, so let me take a short break. We'll come back, and I'm just going to stop the stream on YouTube. Again, we'll be back. Right now, we're sitting at about 4:53. Let's say about 5 o'clock. We'll come back, so about 7 minutes. We'll take a short washroom break or a water break or a coffee break and come back in about 7 minutes.